Hello, this is Mr. Cozy, and this is video 51 where we talk about E. E is a new number. E is like pi. It has kind of pi. It's in the same category as pi. It's a number that's important enough to have its own letter. And so let's we are going to develop E, define it, and then talk about its properties. So let's get started. One thing that we learned the other day was that compound interest has this property where the more often you compound, the more money you make. So let's review the formula for compound interest. A equals P times 1 plus R over N to the NT power, where R is our rate of growth, N is the number of times we compound in a year, and T is years. Okay? And so let's look at $100 at a 10% rate of interest. And let's have that money for 5 years. And let's look at two scenarios. One is that the money is compounded once a year. And the other is that it is compounded every day. And you may be seeing where this is headed. If I set this up for once a year, starting amount is 100 times 1 plus R over N, 0.1. Now, once a year is 1 to the NT power, so 5 times 1, or 1 times 5. Okay, if I work that out, 100 times 1 plus 0.1 divided by 1 to the power of 5 times 1, I'm going to get $161.05. Okay. Once, if I do every day, that's going to be 100 times 1 plus 0.1. Now, every day is 365.25 because of leap year. So that's N every day. And it's going to be 5 years times 365.25. Okay. Let's enter this in. 100 times 1 plus 0.1 divided by 365.25 to the power of 365.25 times 5 is going to give me $164.86. So I compounded more often and I got more money, which makes sense because every time I compound, I add interest. And every time I add interest, there's more money in my account that's going to generate more interest. So the more often I compound, the more money I make. And the question is, does this continue on forever? Can I compound? Can I compound 20 quadrillion times a year? Which is very often, and get a ton of money out of my $100? Or does this level off? If as I compound more, do I technically make more money, but I level off in how much I make? So here's the question we are trying to grapple with. Does compounding more eventually equal infinitely more money? To figure this out, let's look at a particular scenario. Let's look at $1 invested at 100% interest for 1 year. So there's a lot of ones here. The only thing that we will change is how often we compound. So my setup is going to be A equals 1 is my starting amount. times 1 plus my rate is 100%. I'm going to change how often I compound, and I'm going to raise that. It's 1 year, so t is 1, and n is how many times I'm compounding. So how is this amount of money that I'm making going to change if I compound more often? And let's look at some different scenarios. Let's look at once a year. Let's look at once a month. Let's look at once a day. Let's look at once an hour. And let's look at once a second. That should be enough to see how this is going to work out. And so if it's yearly, my n is 1 once a year. If it's monthly, n is 12. If it's daily, it's 365.25. You know what? Let's not make things overcomplicated. Let's just say 365. Let's not worry about leap year. If it's hourly, I need to multiply 365 with 24. And I get 8,760 hours. And if it's by the second, I need to take this hours times 60 to get minutes, and I get 525,600 minutes. Rent fans, pay attention. If I multiply that by 60, I get seconds. I get 31,536,000 seconds. Okay, so I am going to run this equation here again and again and again and again, and change n and see what I get. Okay, so let's start out with 1. 1 times parenthesis 1 plus 1 over 1 to the power of 1 times 1 times 1. And I'm going to get 2, which makes sense because at 100% rate of growth, I will double if I compound once a year. Okay? So let's take this and let's change some of these 1s to 12s. I get 2.61303 ... Okay, so going yearly to monthly, I made quite a bit more. Going monthly to daily, 365. Let's change this 12 to 360. Insert 5, and I get 2.714567 ... I have an extra 1 here. There we go. If I go hourly, let's change this 365 to 8760. 87.6, insert D. 2.71812669 ... If I do every second, let's do this once more. 31,536,000. 31,536,000. I'm going to get 2.71828247 ... So what's happening? Are we making infinitely more money, or is it leveling off? And hopefully you're seeing that this is leveling off. And if I keep going, if I keep increasing n, the larger n gets, the closer this amount comes to a number called E. E is 2.61303 0.718281828 ... Now, despite appearances, E is like pi. It is non-terminating and non-repeating. It is an irrational number or a transcendental number. And E represents, among other things, E has a lot of neat properties, but in this context, E represents continuous growth. It represents the limit of what you get as you compound more and more and more and more and more often. Okay? So this is E, and this is what it represents. And every time we see a situation where we have continuous growth, we're going to use E. Now, as far as properties of E go, E's like any other base. So all of the other properties that you know about manipulating exponents apply here. If I have E to the 2x times E to the 3x plus 1, I'm going to do exactly what I do any other time and add my exponents. Okay? If I divide with E, I'm going to do anything that I'm going to do what I do any other time and subtract exponents. And if I have a power to a power situation, I'm going to multiply exponents. That's not going to change. Okay? All right, so we'll talk more about E tomorrow and how it's used, but this is where it comes from. And I'm going to cut you off here. Have a great day, and I'll see you later. Bye.